Hello students, today's video is going to be on the topic of distance formula, that is 28th chapter. So as the name suggests, will be understanding how to calculate the distance between 2 points if their coordinates are given. So let's have a look here. So this is a coordinate x-axis as well as y-axis. This is origin. So let us consider 2 points. 2 points. This is A and this is B. So I'll write x1 comma y1, then B x2 comma y2. So A and B are the 2 points here. So let us join this point. Now the x coordinates are always called as abscissa and the y coordinates are always called as ordinates. So since the abscissa of point A is x1, therefore its distance from the origin on the x-axis, so this is x-axis, will be x1 here, will be x1. So similarly, its distance from the origin on the y-axis, so this is y-axis, so will be y1 here, y1. Now since the distance, and this is y2 and the whole thing is x2 here. This is x1, this is y1, this the whole thing is y2, y1, y2, x1, x2. Now since the distance x2 is greater than x1, therefore the length of AC, so here, so I'll write this is C. The length of AC will be x2 minus x1. x2 minus x1. Similarly, the distance, this is y2. So this y2 is greater than y1. So therefore BC. Therefore BC is equal to y2 minus y1. Now if you look carefully, you will notice the triangle ABC, a right angle triangle with AB as the longest side. So this is the longest side, that is hypotenuse, this is perpendicular and this is base. So by Pythagoras theorem, we will have hypotenuse square is equal to the square of sum of other two sides. So this is nothing but x2 minus x1. AC is nothing but x2 minus x1 and BC is a y2 minus y1 here. Therefore by Pythagoras theorem, I can write hypotenuse square is equal to the square of sum of other two sides, that is AB square equal to AC square plus BC square. So therefore AB square is equal to, so put these two values AC and BC in this, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. So therefore AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. This is the distance formula. So even if you interchange the places of x1 and x2, the values of the formula still remain the same. So if you put x1 instead of x2 and x2 instead of x1, we will have, that is AB is equal to x1 minus x2 the whole square plus y1 minus y2 the whole square. Here, so here the answer will still remain the same, because ultimately we are squaring each bracket here. So therefore AB is also equal to root of x1 minus x2 whole square plus y1 minus y2 the whole square. Got it? So this is the distance formula, that is AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So let us zoom out to understand the special case of the distance formula. So we have a line like this. So this is a point. This is x coordinate, this is y coordinate. So this is origin. So I'll write this one as A here. Okay, instead of writing x2, y2, I'll write A as a x comma y and x1 y1. So I'll write origin 0 and 0. So in this case x2 comma y2 are x and y. So I have taken x and y, and x1 comma y1 are 0 and 0, 0 comma 0. Therefore the longest length OA is equal to square root of x minus 0 whole square, that is x2 minus x1, y2 minus y1. So x minus 0 whole square plus y minus 0 the whole square. So this is nothing but x square plus y square. So if the line segment start from the origin, its length will be the square root of, that is x square plus y square, that is OA is equal to square root of x square plus y square when the origin is 0 and 0. Understood? So let us take one example. So let's look at our first question here. The first question is find distance between points 3, 6 and 0, 2. Okay. So let's say that 3 and 6. 3, 6 is equal to x1, y1 here. Okay. Then 0, 2 is equal to x2, y2. So by using distance formula, what we get? By using distance formula, that is nothing but x2 minus x1 square. x2 is a 0, x1 is a 3 here, 3 square plus y2 is a 2, x1 is 6 whole square. So this is nothing but minus 3 square plus minus 4 square is nothing but 9 plus 16 root of 25, that gives 5, because root of 25 is a 5 units. 5 units. Understood? Now next we have the second question, that is find the distance between origin and the point minus 12 and minus 12 comma 5. Now we know that the coordinate of the origin is always 0 and 0. So let 0, 0 be x1, y1 here, and minus 12, 5 is a x2, y2. So by using again distance formula is nothing but x2 minus x1 square. x2 is a minus 12 minus 0 square plus 5 minus 0 square is nothing but minus 12 square plus 5 square. So 12 square is a 144, 5 square is a 25. That gives 169, which is nothing but 13 units. So this is the answer. Clear? So let's take one more example. So this is our third example. Find the coordinates of points on the x-axis which are at a distance of 5 units from the point 6, 3. So now, here let us consider 2 points. Find the coordinates of points on the x-axis which are at a distance of 5 units. So 5 unit is already given here. 5 unit. So 5 is equal to, here you have to use the distance formula, that is x-axis. Points on the x-axis which are at a distance of 5 units. So here you have to take the 2 points are x comma 0 and the given 6 minus 3 are the 2 points. So 5 is given already. So write square root of x1. So this is x1. So x, so minus 6 whole square plus 0 minus of minus 3 whole square is nothing but x minus 6 whole square plus minus into minus is a 3 whole square. So now to remove this square root, so we have to remove this square root. We have to square on both sides, that is 5 square is equal to x minus 6 square. What we get? So after squaring on both sides we get x minus 6 square plus 3 square. Now simplify this. Now that is 25 is equal to, so this is the formula of a minus b whole square. A minus b whole square is nothing but a square minus 2ab plus b square. So this formula we have to apply here. That is x square minus 12x plus 6 6 are 36 plus 3 3 are 9. So this implies x square minus 12x plus 45. So this 25 is equal to 45. Now x square minus 12x. So 45 minus 25 is a 20. Is a 20, which is equal to 0. So solving this equation by the method of factorization, we will have x square. So this 12x means this is, I'll take this 10x minus 2x plus 20 is equal to 0. You know how to find out the factorization. Okay, you studied in the previous class. That is, so which is common in between these two? X is a common. So x minus 10 minus 2 into x minus 10 is equal to 0. Now x minus 2, x minus 10 is equal to 0. Therefore x minus 2 is equal to 0 and x minus 10 is equal to 0. That is nothing but x equal to 2 and x equal to 10. So our required points will be 2, 0 and 10, 0. is 10. 10, 0. So this is the answer. Understood? So let us take one more example. A point A is at a distance of root 10. Point A is at a distance of root 10 units. From the point 4, 3, find coordinates of point A if its ordinate is twice its abscissa. Twice its abscissa. Abscissa means x points, that is x values. Okay, now let's see. So again, let's begin by saying that let the point A be x, y here. Okay. Since they are given ordinates are twice its abscissa, means that is ordinate y is equal to 2x. Ordinate y. Ordinate means y-axis, that is y coordinates, that is y is equal to is twice its abscissa, means y is equal to 2x. So let us consider y is equal to 2x. Therefore here point becomes what? Point becomes, that is a of x and 2x. X and 2x. Now they have already given the distance root 10 units. Okay, so by using distance formula again, it is x minus, point is given here, 4x minus 4 square plus the second is a 2x, that is 2x minus 3. 2x minus 3 whole square. So that is, by squaring on both sides, what we get? 10 is equal to, so this is x minus 4 square plus 2x minus 3 square. It is nothing but 10 is equal to, so simplify this one by using the formula a minus b whole square. A minus b whole square is nothing but a square minus 2ab plus b square, that is x square minus 8x plus 4 for the 16 plus this is 4x square, 3 to the 6, 6 to the 12 minus 12x plus 3 to the 9. 3 to the 9. So this is x square plus 4x square is a 5x square minus 8x minus 12x is a minus 20x. 16 plus 9 is a 20. 16 plus 9 is a 25. Okay, now transfer this 10 this side. What we get? 5x square minus 20x plus 25 minus 10 is equal to 0. Therefore 5x square minus 20x plus 15 is equal to 0. Now here common term is a 5. So take out common 5. X square minus 4x plus 3 is equal to 0 here. So this is x square minus 4x plus 3 is equal to 0. So after using factorization method, so we get, so this x square, so 4x I'll write it as 3x minus x plus 3 is equal to 0. So what is common? You take out, that is x is a common here, x minus 3, so minus 1, x minus 3 is equal to 0. X minus 1 into x minus 3 is equal to 0. X minus 1 equal to 0 and x minus 3 is equal to 0. Therefore x equal to 1, x equal to 3 here. But what we said, the points become x and 2x. Why? Because here its ordinate is twice its abscissa, means that is x and 2x. So here are the points, that is 1 and 3. 1 and 3. So put these values, that is in this, that is x and 2x. What we get? So a is equal to 3 means this is 3. Its double means that is 6. Okay. Then or. So or here this is a 1. Its double means it's a 2. So the points are 3, 6 or 1, 2. So this is the answer. Understood? Let's move on to the next question. That is our fifth question. Prove that the points P 0, 4, Q is a 6, 2, R 3, 5, and S 3, -1 are vertices of a rectangle PQRS. So what we have to prove? So these 4 points are the vertices of a rectangle. So let us draw the quadrilateral. You know how to draw the quadrilateral of a rectangle. This is a rectangle. This is a rectangle P, Q, R, and S. So the points of P is a 0, 4, 6, 2. R is a 3, -1. S is 3, -1. R is a 3 and 5. So for PQRS to be a rectangle, opposite sides are equal. So opposite sides are equal. Here PQ is equal to SR, then PS is equal to QR or RQ. QR. Now let's see one by one. So first one is a PQ is equal to the root of, by using distance formula, PQ x2 minus x1. x2 minus x1, that is 6 minus 0 square plus 2 minus into -4 square, that is 6 square, plus minus into minus plus, that is 2 plus 4 is a 6 square, is nothing but root of 36 plus 36. That implies root of 72 units. 72 units. This is PQ. Now let us see SR. SR, that is 3 minus 3 square, 5 minus into minus plus 1 square, nothing but 6 square plus 6 square, so which is also same, that is 36 plus 36 is equal to root of 72 units. So this is 1, this is 2, so this is SR. So therefore PQ is equal to SR here. Now we have to prove PS is equal to QR. So distance of PS is equal to distance of QR. So you can calculate and find out the distance of PS and QR. So you will get PS as a root 18 and QR as a root 18 units. You can try that and get the answer. So hence it is a rectangle because PQ is equal to SR and PS is equal to QR. Hence PQRS is a rectangle. So let's solve our last question, that is sixth question. Find the area of a circle whose center is 5, 3 and which passes through the points -7 and 2. Find the area of a circle whose center is 5, 3. So this is a circle whose center is 5, -3. So this is a point. Center is a 5, -3 and which passes through the points -7 and 2, which passes through the point that is -7, 2. That means this point will on the boundary of the circle. So distance between 5, 3 and -7, 2 is nothing but this is what? This is radius. So therefore I can write this radius R is equal to so these two are the points, that is so we'll find out by using the distance formula, that is radius R is equal to 5 minus of -7 square plus -3 -2 square. It's nothing but this is 12 square plus 5 square. 12 square plus 5 square is nothing but root of 144 plus 25 is nothing but root of 169 is equal to 13 units. 13 units. So this is what? Radius R is equal to 13 units. Now we have to find out the area of a circle. Therefore area of a circle is equal to area of circle is a pi r square. So pi, the constant value, that is nothing but 3.142 into r. We know that r is a 13 square. So 3.142 into 13 into 13. So approximately we'll get the answer 530.66 square units. So, okay guys, hope you found this video helpful and please solve the exercise 28. So this is the homework. Thank you.